15 minutes gone, nonsense discussions. Potential energy. So we said that potential energy is the energy possessed by a body by virtue of its position or due to its position. Okay. So in when we were talking about kinetic energy, we were talking about motion, that is velocity. In potential energy, we would be talking about the word position. Okay, position. Now, this position that a body might have may be due to two reasons. Either position means a sort of configuration which you are right now in. Either you might be constrained, so you have a position. Like if you are a spring, suppose you have a spring like this, and then right, and let's say this is point A of the spring, and I have compressed the spring now. This is point A. This is also a position. Earlier my position was something like px1. Now my position is px2. So px2 is a different position. Here also I have some potential energy. Here also I have some potential energy. Now this change of position is due to a sort of constraint that we have done. Okay, this is due to a constraint. So when you actually are looking at potential energy due to a constraint, this is known as the elastic potential energy. Right, like a stretch bow, a stretch rubber band, or whatever it is. And then there can be one more, which can be due to a height as measured from a reference level. Now, as you are measuring from a reference level, usually from a reference. So usually this reference is taken as, say, Earth's surface. Then this is known as gravitational potential energy, and this is what will be of interest for us in this particular term. Now, question comes that let us say, suppose I have a surface like this, and there is a body, and this body is at a height. Let's say this is the height of the body. The question arises, here what do we measure? Do we measure, now this is a little bit higher level, do you measure potential energy? You cannot measure exact potential energy. This will be something which you'll be talking in class 11. You always measure what is known as difference of energy. Any measurement that you, what is your age? 16 years. Why? Because you took your date of birth as 0, means as the level or as this reference level. Now you are measuring the height from the surface of the earth. You could have also measured the height from the center of the earth. So whenever we measure at this, we have to take some reference. So at this reference, we say body does not have any height. Let's say the body is out here. It does not have any height. So we will write that potential energy is equal to 0. Have you understood? And from here you are building up. So whenever we measure anything, we say, like you say, this boy is a smart boy. And what is the definition of a smart? Because of all the boys you have seen so far, you feel that this boy is outshining everyone and he's smartest of the collection that you have seen. Tomorrow you see another boy, because your baseline is what you have accessed so far. Based on that, you find this boy smart. Tomorrow you can find an even more smarter boy. So potential energy, whenever we measure, it's actually the difference in potential energy. But for somewhere we have to have a reference. The reference we have given is like day, time. What is the year today? 2026. Because 0 was taken as to be the common era, or in the 0 AD, in the year of our Lord. So 0 Anno Domini, that is, we have taken that as the reference. Otherwise, तो उसके पीछे भी तो time था, है ना? So it's the same thing. PE is 0 assumed when height is 0. When the height is 0, P is 0. Once a body has changed a little bit of height, does its position change? Yes. So this body's potential energy will change. We at our level will not be talking about elastic potential energy. We will be talking more on gravitational potential energy. Now, let's see how to derive the expression for gravitational potential. Oh, sorry, I'm so sorry. Likh lijiye beta. Sorry. Have you understood the concept of potential energy? Right? Energy by virtue of position. This position may be if you are constrained, or this position may be. By the time as she is writing, I wanted to ask one more thing. In your schools and all, in grades, say 1, 2, 3, 4, 5 and all, do you all have like storytelling competition? Show and tell? Show and tell? And at your grade levels, do you all have something called extempore speech?
Yes.
And how are the children selected? Like, I'll tell you how ours used to be. We used to have 4 houses. So every Saturday, last 2 periods used to be CCA, co-curricular activities. So they will announce that the next competition is extempore speech. So this week CCA, every house will sit in their allocated rooms with the house master, who will be some physics teacher or bio teacher. So within that, the teacher will select by some internal competition, and the next Saturday will be the finals of extempore speech. Now every house will be sending 2-3 stalwarts. This is how we used to do. Do you have such every week? Hey, see, that difference is showing up. In our times, we used to have. And they can be from extempore, debate, mono acting, quiz, instrument play, then solo song competition, what do you call, group song competition. Then we'll have drama, एकल गायन प्रतियोगिता, solo song competition. ऐसा होता था. Everything, A to Z. चलते हैं फिर अगला स्टोरी. हाँ.
Kinetic energy said body with kinetic energy can do work. What about body with potential?
Everybody, energy hai. No, first go to energy. If you have energy, you can do work. If you have electrical energy, also you're doing work. Got it? That is called the work energy theorem. All the energy inside me can make me do work. And if you do external work on me, then energy inside me, you are spending your energy. You are doing external work on me by pushing me. What about your energy drained down? Where is that energy come? That energy has been stored in me. You did work by spending your energy, which has been stored as energy on me, because you have pushed me now. Can I now not push you back? Yes. ठीक है ना? तो आइए expression देखते हैं. Expression for, and hence on, if I write potential energy, it is auto understood that we are talking in terms of gravitational potential energy. Right? So let's see the expression for potential energy. गुस्सा हो गए हो तुम लोग आज मेरे ऊपर. हाँ, ये आदमी खाली आके हमें एहसास दिलाता है कि हम कुछ नहीं करते हैं. He's a very bad man. Every day he's coming and telling all nonsense things. Okay. Right, this is a body. Obviously, if this is a body, this body should have some sort of mass in it. Right? And due to its mass, it should also contribute to some sort of weight. So the weight of this body, the weight is also equal to a force. I have explained it to you. And this is equal to the mass multiplied by the acceleration due to gravity. This I have explained. Weight of a body, understood? Right? Now this body is to be lifted, and it is being lifted without any acceleration. So we are lifting it to a height, let's say, to this much height. Right, fine. So we are lifting it to this height. And let's say our height is h. H is the height through which the body will be now lifted. Okay? So let's bring our body. Take. And you are lifting it with zero acceleration. That means net force acting on the body should be zero. What happened, sleepy? Net force acting on the body should be zero. So while to lift it, you have to apply a force which is exactly equal to the weight of the body. So that upper body and lower body, net force acting on it is zero, right? So how much force you will be applying? You will be applying a force which is exactly equal to the force that is the weight of the body. So this force is how much? This is F. F is your force, right? Now let's see. By our definition, work done. Work done. Work done is always given by force multiplied by displacement. Displacement multiplied by cosine of the theta between them. We're going by basics, right? So if you see it in vector method now, your force is acting in this direction, and your displacement is also happening in this direction, right? This is my force vector, this is the force vector, and this is my displacement vector. Both are here. So my theta in this case will be 0 degree. And if my theta is 0 degree, cos 0 is equal to 1. Okay? So the work done is given by how much force, which is F multiplied by the displacement. The displacement is nothing but H. That much of distance you are moving it, right? And cos 0 is equal to 1. And the value of F is equal to how much? M into G, because that force has to be equal to the weight. So this is the work done. And this work done gets stored as PE in the body, right? Now the question is to lift it from here to here. So see what I'm writing something now. To lift it from here to here, you did work, and this work was equal to mgh. Now once it has come here, it is energized. And the energy content in this body is now mgh, because this has to tally this. And since this is due to a height, so I will call it as the potential energy. This is what happens when water comes. All the water is coming to our apartment right at the ground level. Then through pumps, we are lifting it on the tank. Now from tank, you just open the valve, the water will rush down because it has got energy in it. And while rushing down, it can rotate a turbine. So it can create kinetic energy, which will make the turbine rotate. The rotating kinetic energy can then convert it into electrical energy. Same thing we do in hydropower projects. All the water which is falling from waterfall, those are having potential energy. They are falling on the blades, right? And those blades that potential energy is converted to kinetic energy. And that kinetic energy will rotate the blades. And that will create electricity. So potential energy to kinetic to electrical energy. Have you understood this? Yeah.
To give the water example.
When
the water is now, doesn't it have kinetic energy?
It is losing. Right now, kinetic energy is 0. It is stationary. The moment I leave it, it is starting to gain kinetic energy. Where is it gaining the kinetic energy? By losing the potential energy. वो देखेंगे अभी यहाँ पे. Yes, ठीक आया, समझ में आया? The expression. So you got two formulas in this chapter so far. Kinetic energy is given by half times mass into velocity square. Potential energy is given by mgh. We'll do some numericals based on that. And if somebody tells you what is the work done, the work done is always the change in energy. Change in energy. Okay? Can I change the screen? Okay, no issues. More than that, I hope you have understood this. You did work and that got energized. ठीक है? चलेंगे आगे आराम से. केमिस्ट्री और एक ही चैप्टर है बेटा. हाँ, इसका भी और एक ही है, इसके बाद और साउंड है. After this, we have to do power, and then there's a new section that has been introduced in CBSE, that is machines. Machines were not the simple machines. You will have class 1, class 2, class 3 type of machines. Yeah, the pulley, fulcrum, you'll study. This used to be there in ICSC. You'll learn about mechanical advantage, velocity ratio. नहीं, simple machine एक ही चीज आपने पढ़ा है, the pulley, the lever and the fulcrum. हाँ, अभी यहाँ पे हम पढ़ेंगे पुलिस के ऊपर प्रॉब्लम होगा. I don't know, I have to see the syllabus. Okay, चले आगे. So let's now talk about something called conservation of energy. What is the law of conservation of energy? The law of conservation of energy tells me that energy can neither be created nor be destroyed. Okay, the law of conservation of energy tells me energy can neither be created nor be destroyed. That is, it can only be converted from one form to the other. In short, total energy of a system is always constant. ये लास्ट लाइन का मतलब समझा ना आप? Money in your pocket can neither be created nor be destroyed. It can only be converted into different forms of money. In short, the total money in your pocket is always constant. Money can be converted to cash memos. Cash memos can be converted back to money. If you have sold it to someone, again got money, right? So if this is the universal law of conservation of energy, and it is applicable for all types of energy, and now I'm putting my small line out here that I will try to see this law for mechanical energy of a body. Sir, is this that the law is conservation of mechanical energy? No, no. The law is law of conservation of energy. Law of conservation of money. It can be for dollars, rubles, euros. So we are going to study it for rupees today. One type of energy, which is mechanical energy, but that's what we have studied. And as he was saying, if a ball starts to roll down from a roof, so its height is reducing now. So obviously, its potential energy should reduce. And if the potential energy reduces, it has to get converted into something because you can't destroy it. So we'll see whether this law is actually correct or not. Mathematically, we will prove that. So how to prove it? So let's conceptualize a system where we have overall a height, and let's say there is a body which is allowed to fall through this height, right? These are two positions, and let us say that this is the datum position. Datum means reference, D-A-T-U-M. Datum means this is my reference. Okay. This height is h, right? My object is a small body of mass m, and this body is first here. All right, then we'll take it at some arbitrary point somewhere here, and then we will analyze it for some place here. पहले समझो, मैं आपको लिखने का पूरा टाइम दूंगा, ठीक है? This is a body is at a height h. Do you agree? And all these things will be seen as three scenarios. Scenario 1, scenario 2, and scenario 3 is the same ball. The ball is falling from a height h. So obviously, one more thing that we need to specify here is what is the, we need to find out at what level is, sorry, everywhere we have shown the height at. Right. And let's say that this much portion, this distance is x. All right. So what is this much portion? Very good. So this portion is h minus x. So you have understood, right? Can I make this small now? Okay. So all we have to prove is total energy remains constant at any point of time. So our analogy will be, we have kept the ball at position 1, the ball comes down to position 3, and in between we have taken some intermediate position 2, right? Our job is to prove that the total energy of the body is constant, means it is not losing any energy, and only conversion of energy is happening. That means total energy at 1 should be the same as total energy at 2 and at 3, right? So let's start our analysis. Okay, let's start our analysis and see how it happens. Let's say at position 1, let us see what all things are happening. Body is at height equal to h. The velocity of this body is equal to 0. Do you agree or not? पहले मत लिख बस एंजॉय करें. क्यों तुम्हें मजा नहीं आता है तुम लोगों को पता है? बिकॉज either you all, I don't know what you all eat and come. Do you eat and come for my class or not after coming from school? Please eat. And I don't mind you carry some almonds, some cashew, some what you call any tidbit beta. I'm all okay as long as you don't litter it. But I want energetic faces because you are my first class. After that, I've got 2 more classes. I'm at. If we look at him, his face, he's like allowed to give a chance. Put him on the driver's seat. All passengers perish to death. You don't have school also. What stops you from sleeping in the afternoon unless you went somewhere? Look at his face. Some loan recovery people has come to his house and thrown utensils outside. जोश क्यों नहीं है बेटा? I have taught you motion. You didn't find interest there. I taught you force. You didn't find. ये एक बच्चा है जो हंसते रहता है और एक रैन को मैं तो हंसते देखता हूँ. Anytime अभी क्या टाइम? Okay, whatever he has written. Dog ate a cat. मैं वही लिख लूँगा. ये अच्छा नहीं लगता है. मैं आपके साथ ज्योग्राफी भी पढ़ सकता हूँ. But I want. If you see Nitya. Just now, where is Nitya? She is not yet come. Why? No, the ambulance from Continental Hospital has not yet come. Girls and boys, you are at the 15th year of your life. Your with youth and vigor should be sprouting like anything. At 15th year, people used to say, हम लोग को अरे चुपचाप बैठो क्या जोश में रहता है. You may not like this. ऋषिका को देखो. इतना टायर्ड हो जाते हो अगर ना, इतना टायर्ड नहीं होना है बेटा. You're going by a bus. In some cases, you're going by AC bus. You're coming back by bus. The only hard job you're doing is carrying a bag from the bus stand to this. That also your mom and dads and all feel such as if you are like Hercules, god of Greek god Hercules. Little bit it rains, all of you will be taken like fairies in car. By the same parents, that is my age group people, who all went walking to a bus stand. I didn't go walk. My dad went walking to school. Initially barefoot, then he made me go by a bus, but the bus is to come by a place. I'm making my daughter now travel through what? AC bus. ठीक है यार, क्या hard? If after that, if you have no strength, na, that means all girls I'm saying, I mean, I'm not joking. Your parents don't take it seriously when I say, in our country, every one of us is iron deficient. Children, if you are in teens and you are at that 14th, 15th year and you are a girl, get your iron profiling done before it's too late. आप सुन नहीं रहे हो. Stand in front of the mirror and pull your both eyes down, and if you don't see pinkish, that means you are deficient in iron. Simple. And the iron deficiency will slowly make you सब में है, and it will slow. That with your face I can make out. You are fairer than me, na. I'm not talking racist. You're fairer than me. ये बच्ची फेयर है ना, फिर वो रेडनेस क्यों नहीं है फेस में? रेडनेस क्यों नहीं आ रहा है आपके फेस में? इसका मतलब आप खाते नहीं हो ठीक से. हर किसी चीज का टाइम है बेटा. खाना नहीं खाओगे पेट भर के, क्लास में आते हो मनी, एंड इट्स नॉट विद यू. 10th grade, 11th grade, all. आई एम नॉट ब्लेमिंग यू ऑल. यू ऑल आर ऑल फ्रॉम इकोनॉमिकली गुड वेल सेटल्ड घर. खाने से कोई मना करेगा आपके घर में? मे बी योर पेरेंट्स विल दैट दे थैंक गॉड आज मेरे बच्चे ने 2 रोटी खाया. Do you ask for additional food? मुझे और दो. I'm not saying all this pasta. मुझे और दो. दोपहर को if you are a North Indian, you have रोटी, माँ एक और रोटी दो. नहीं मांगते हो. भूख ही नहीं लगता है आप लोगों को. तो भूख लगना है बेटा. ये फेस में आप लोगों को देख के मुझे लगता है कोई जोश नहीं है, कुछ नया सीख रहे. अरे how will sir prove that the energy is same? What is he is going to apply? मेरे जगह अगर यहाँ पे ना कृति सनोन आके भी पढ़ाएगा ना तो भी आप लोग ऐसे ही रहोगे. यस क्या जोश ही नहीं. चलो, bodies at a height h, velocity is 0. This makes me say that the kinetic energy at my position 1 is equal to 0 because there's no velocity. Kinetic energy is equal to half mv square, and the body is at height h, and the body mass is equal to m, and the mass m will always be constant, right? Whatever position you are. Agree or not? So here the potential energy of the body at 1 will be equal to magaha mgh. Correct? So if I see the total energy at position 1, it is equal to the kinetic energy at position 1 plus the potential energy at position 1, which is equal to 0 plus mgh, which is equal to mgh. So we have derived one expression that what is the total energy of a body right at the top. Have you understood this or not? Very good. Fine. Let's say now at position, now this is critical, at position 2, right? What happens to the mass? Sir, mass gets reduced. Mass remains m, right? And let's say the velocity is equal to v. यहाँ पे एक velocity भी तो होना पड़ेगा ना at position 2. Let's say the velocity is equal to v. The height. What is the height of the body? H minus x, right? The height is equal to h minus x. So it's a very nice thing. Since you have a velocity v, that means this body must be having kinetic energy. It must be having kinetic energy, right? And it is having kinetic energy and it is also having potential energy, right? This proves from here we get that the body at K2 there will be a value and PE2 also we will have a value. Let's first find out what is PE2. That is a bit easy. PE2 will be mass mg into h minus x. Do you agree? That is the height. Height is always measured from the bottom, right? Let's see our expression for Ke2. Ke2 will be equal to how much? Half mv square. Agreed? But is this uniformly accelerated motion? Yes, you are under the acceleration due to earth, straight line motion. So third law is applicable out here, means Suvet is applicable. So I can use my third equation, which is v square is equal to u square plus. Now you're coming along with gravity, you're going along with acceleration, right? U square means 0 because the initial velocity was 0. V square equal to u square plus 2g into what should I take? X, because that much distance you have traveled. So I am taking this as x, which further tells me that v square is equal to 2gx, right? So my kinetic energy now becomes half m 2gx, right? 2gx whole square. V square is equal, no, not 2gx whole square, 2gx, because v square itself is 2gx, right? So 2 and 2 can be cancelled. So finally, Ke2 is equal to mgx. Do you agree now? So let's find out what is the PE, what is the total energy at 2. This should be equal to the PE at 2 plus the Ke at 2. The PE at 2 is mgh minus mgx. mgh minus mgx, distributive property. And what is the Ke2? Plus mgx. These two can cancel each other. So if you see, the value of PE2 is equal to mgx. Sorry, mgh. This is my equation 2. And by now, we have some sweet things coming up. This is mgh. This is also mgh. At two places, we have found that the total energy remains the same. While the potential energy is running down, the kinetic energy is building up. This was a random spot. Our proof is not yet through till we see what is happening at bottom. Shall we? You note this down. Or else we'll finish that and then you note this down. So ek baar mein karo. So let's go to position 3 now. Now we are at position 3. At position 3, mass still remains as m, right? Velocity, just before it reaches position 3, velocity is some v, final velocity is v, okay? And the height is equal to how much? 0. There's no more height. So no more height means the PE has become 0, but this means the body at the third position still holds some kinetic energy. This is position 3 is just before striking the ground, okay? Third position is just before, right, striking the ground. Just before striking the ground. Right. So let's see what is our PE. Pe at 3 is equal to 0, and Ke at 3 should be equal to what? Half m v square, some velocity v. And if you have some issue, then you can, if you want sets at both places how the velocity can be v, velocity will increase, you can put this as v2, so that v2 square. So yeah, if you put it v2, so we'll put this velocity as some v3, right? We'll put this as v3. Fine. So my kinetic energy would be v3 square. Again, straight line equation. V3 square is equal to, it started from here, 0 square plus 2g into the entire h. Now it has traveled entire h. So put this value out here. My Ke3 becomes equals to half m into 2gh. So 2 and 2 cancels. Ke3 is equal to mgh. Now I need to finally say what is T3, should be equal to T3 plus Ke3. T3's value is 0 plus mgh, which is equal to mgh, and this is 3. So no matter wherever you are, the total energy of the body is always mgh. While at position 1, the entire mgh was contributed by potential energy. At position 3, the entire mgh is contributed by kinetic energy, and in between, both of them contributed something. But if I look at my diagram, I was a little bit biased where the height was less than half. So the potential energy loss has been less, and that much of buildup of what has happened, kinetic energy is built. So it's like this. It's like a triangle on this side. As potential energy increases, kinetic energy decreases. Overall energy is same. So just for your understanding purpose, if you try to map it, if you try to map it, something like this. Let's say this is a double index graph, okay? This is a double index graph. And on this side, I say that this is the PE and this is the KE. Total energy always remains constant. So the total energy would be something here. The total energy is here. This much is the total energy. Now, as you are traveling from top to bottom, let's say you're traveling from top to bottom, your PE is coming down. As you are traveling this distance, your PE from here has come down to, what was our total energy? What was our total energy? Our total energy was mgh. So your PE from mgh has come down to 0, right? On this we are showing displacement. Have you understood? On this we are showing energy, on this also we are showing energy, right? And in this process, as your PE was getting lost, your KE from 0 was getting built. So here I have got 0 KE, and here my KE is equal to how much? mgh. Beautiful. That's intersecting point is half of Ke is lost and half of P is there. And here this is 0 PE. Did you understand this graph? So that means if you see from one axis, this is PE axis, P was at mgh, and over this displacement P, and this one, and in between there is a handshake here. At this point, exactly P and Ke are same. तो आप एनर्जी बढ़ा नहीं सकते हो. हाँ, एनर्जी कैसे बढ़ाओगे इसमें? सर, if you increase the height, but for that you have to put a motor which will run and pull it up. Some work has to be done. You can't increase the energy. Energy of this universe can never be increased, nor can it be decreased. You have to do some work. You say, no sir, I still want the water to splash with much more higher velocity. We can do that. Jack up the PE. How do you jack up the PE? By raising the height of the water. For that, somebody has to, some mehnat you have to do, right? That mehnat is known as work. And that work we are spending to build up the energy. चलो, अब कॉपी करो आराम से. हाँ. फोटो, हाँ आराम से. ये आप फोटो लेने से अच्छा मैं स्क्रीनशॉट डाल दूं. टीम्स में ये तो लगे दिस इज अ कंप्यूटर ना, वी कैन टेक इट स्क्रीनशॉट। आप लेना चाहो तो ले लो, ऐसे भी क्लास रिकॉर्ड हो रहा है बेटा, along with the आयरन की डांट, along with the आयरन की डांट। इतना कौन, हाँ हाँ, कल से मैं एक लोहड़ी का कैसेट, हाँ हाँ बिल्कुल, जो इच्छा, कल से एक लोहड़ी का कैसेट लेके आऊंगा। हाँ सोने का गुड बाय जूस। हाँ ठंडा पानी नहीं है, ठंडा पानी पीना ही नहीं है, आई हैव नॉट टर्न्ड इन ऑन। शर्म नहीं आता है, बीमार होके पड़े रहते हो, यू लेस इम्यून चाइल्ड, और इधर ठंडा पानी पीना है, और फिर बीमार पड़ के जाके घर में बोला सर के घर पे ठंडा पानी पिया था, दे सर को बर्बाद कर। हाँ आपको मूवी देखना है इसमें, आपको जो अच्छा मुंह में कुछ है, जो इच्छा बेटा आप अखरो, आई रादर व्हाट आई से यू नो, टॉफी उफी लाने से अच्छा है आप अपने छोटे कटोरे में ना, आई एम टेलिंग यू, एट 3-4 आमंड्स इन दैट, बादाम समझते हो, 3-4 बादाम, 3-4 कैश्यूज, और मुंह में टेस्ट रहेगा, कुछ आपको एल्पेनली भी रखना है रखिए, और थोड़ा सा किशमिश रखिए, बट ऑल द एंड इज दैट यू आर कीपिंग दैट टू कीप योरसेल्फ अवेक। Why? Because that will only be a stopgap arrangement. सबसे पहले why the sleep is coming, that you have to attack. In your age we used to come back from school, same, my school used to be over at 3:45, so what time I will come back home, तभी उतना ट्रैफिक नहीं था, 4 बजे तो नहीं होता था, 4:20 तो मिल्कमैन रन तो मारेगा ना बस, 4:20 घर आके मदर विल बी रेडी विद फूड, फूड भी खाना है, पेट भर के खाना खाया, एंड देन इमीडिएटली जूता उता पहन के पैट बैट लेके चले गए, एंड वी आर इन असम, दैट मींस आफ्टर 5 इन समर्स, आफ्टर 5:30 you can't bat because you won't be able to see the ball. Winters में तो by 4:40 4:30 रात हो जाता है, so come early and immediately go, otherwise play different sport like football or fly kite, और बैडमिंटन खेलने के लिए लाइट्स में तो देगा नहीं अंकल लोग, because in your township clubs and all, once the lights are on it is seniors playing time, you can't play, not like nowadays, and if you play some other person will come, how come this Rajiv Sharma's daughter is playing badminton out here, right? We are supposed to use tennis court, badminton court, someday when the light is on and nobody is there, एक शटल मार लिया ना, लाइट में खेल लिया आज, not allowed, not allowed, simply not allowed. If it's a party where kids are not allowed today, means kids are not allowed, no kid will be there out there. That's why at our age there used to be some Christmas party and Christmas ball where 16 up were allowed. That day we used to really feel elite. 16 up, we can go and join that party. We grew up like that. Not allowed, not allowed. सब घर में रहते थे, कोई डकैत डाकू चोर उठा के लेके नहीं जाता था हमें। And all houses far away, 3-4 townships are there, ONGC, Oil India, Indian Oil, so we'll we have to go to Adya's house, so we'll go take our cycle, go to Adya's house, reach her house, keep the cycle, then use her phone, land phone, call my mother back, मैं पहुंच गया, बस, that's all. In between, neither my mom will nag or not, again after coming back from her house or party, again call her mom, auntie मैं पहुंच गया, बस, loop closed. हम कभी खोए नहीं। और अभी क्या, ट्रैकिंग किड वॉच, ट्रैकिंग किड वॉच है ना, go now to Ratnadeep, you will see all kids with tracking kid, enough of foul words on the mouth, or when you come from B Tower basement there's a dance room, right, all of them will be parking cycle there, and you see बोला क्या language use करते हैं, my god, F letter word, 4 letter word, you bro, you don't understand, you really suck, इतना बच्चे। This is very essential. This I've kept now for grade 8. If mistake, उसने दिया एक को नकल में, है नकल में देना, फिर ये अंदर में घुसा के दबा देना। एवरी टाइम ही इज मेकिंग दैट मिस्टेक। बोला और नहीं लिखते हैं, इक्वल टू लिखते हैं, फिर भी लिख रहा है। अब वो नहीं बताऊंगा, ऐसे लेके ऐसे दबा दिया, वो नहीं, आपको उससे क्या लेना देना। And then this one, they were sitting a little bit ahead, so I have a bigger one of this also. That also, there's a bigger one of this. Crashing is very required. चले, ये समझ में आ गया? So we have some time, 1 or 5 minutes. Let's just see whether we have some problems, and after that we have to do is power. Okay, let's see. हाँ, power है. Work energy power है ना? See a nice problem. Let's do one problem and then it says, what is the power? Oh, this is power. Just छोड़ दो. We need energy. Energy. देखो energy के बाद कितने problems है? You can study from this book only. हाँ. Yeah, let me see. आपको दिया हुआ है. एक ही same है ना? So we have a bag of wheat. A question is, we have a bag of wheat. Once this potential energy portion is over, there are so many questions. Bag of wheat, and there will be theory questions which you will be never answering, and then you don't know how to write your bro. And this bag of wheat is weighing 200 kg is the mass of the bag of. Why did I say this is mass? If it was weight, it would have been in newtons. Okay, so now we need to raise it. This is this bag. This is this bag. Its mass is how much? 200 kg. And this bag is right now lying where? On my head, right? So it's lying here. And they've asked you that calculate a height to which it should be raised. Calculate the height. There will be some height to which it has to be raised, right? So that the P of the body, we don't know what height, so that it gains a P, and this P is equal to 9,800 joules. 800 joules. Such a problem, you can take the value of G as 9.8 meters per second. No, you तो गधे वाली बात कर दी ना, इसमें 9.8 98 नहीं दिख रहा है, फिर भी फिर टेक इट एज 10. यही तो क्लिक नहीं करता है आप लोगों का. दिस क्लिकिंग इज नॉट हैपनिंग बिकॉज यू आर नॉट डिवोटिंग टाइम टू रीड. रीड मीन्स अ स्टोरी ऑल्सो. पढ़ो ना, कहानी पढ़ो. So to what height it should be raised? What is the value of P? कर सकोगे कि नहीं? P's formula is mass into G into height. The P value is already given. So height is equal to P upon mg. What is the P? 9800 divided by m. M is how much? 200 kg. And G is 9.8. 9.8 multiplied with this will give you how much? 1000. Correct? And then this 0, 0, 0, 0, 0 gone. So you're left with 5 meters. That means if you raise it by 5 meters, its energy will become 9800 joules. From next class, I will not call my classes as class. I will change the term, and I'll put this on parent forum also. Our classes will be renamed as memorial service. Memorial service mein lo. Only that there people wear black and come. Here you are wearing colorful dresses. Just before the casket is taken to the abbey or the church, people come for the memorial service, right? Where people, you can wear those hats also with nets and all, black and all. So क्योंकि वैसा ही है ना, इधर कोई बात नहीं करता है, तो memorial service है, class थोड़ी है. Potential energy was very nice. Yeah, tell me. No, weight is not, mass is. 200 cannot be weight. If the weight is 200, weight means it will always be Newton. Weight is a force. Got it? Weight can never be this. So our next classes, we will start with power. So our next class will be a maths class. And next is our last circles class. I cannot spend 4 or 5 classes on circles. Yeah, please do get your next class. Please come with your computational device. If you have a RD Sharma, bring it. If you don't have an RD Sharma, get a computational device. RS Agarwala. हाँ ले आओ जो चाहिए ले आओ.